the last day of the universe. There will come a time when the universe falls completely silent. No stars will shine across the night sky. No galaxies will glow in the distance. Every planet, every sun, and every familiar landmark of the cosmos will have reached the end of its story. The universe won't end with a massive explosion. Instead, it will slowly fade into darkness over periods of time so vast that the human mind can barely comprehend them. The remarkable thing is that scientists already have a good idea of how this could happen. By studying gravity, the life cycles of stars, and the expansion of space itself, astronomers have pieced together a timeline that stretches from today to the very last chapter of the universe. And if our current understanding of physics is correct, the ending has already begun. To understand why, we need to go back to the beginning. Around 13.8 billion years ago, the universe was unimaginably hot and dense. Then space itself began expanding in an event we call the Big Bang. Contrary to what many people imagine, it wasn't an explosion into empty space. Space itself expanded, carrying everything with it. A useful way to picture this is to imagine dots drawn on the surface of a balloon. As the balloon inflates, every dot moves farther away from every other dot. Now, the dots aren't moving across the balloon itself is stretching. Our universe behaves in much the same way. As it expanded, it cooled. Tiny particles joined together to form atoms, and gravity pulled enormous clouds of hydrogen gas together until the first stars ignited. Those first stars transformed the universe. Inside their incredibly hot cores, they created heavier elements like carbon, oxygen, and iron, the same elements that would eventually form planets, oceans, and even life itself. Every atom of iron in your blood and calcium in your bones was forged inside ancient stars that died billions of years before Earth existed. In a very real sense, we are made of stardust. Over billions of years, stars gathered into galaxies, and galaxies spread across the universe in numbers almost impossible to imagine. Yet while the universe looked full of life, something else was quietly happening in the background. It was getting bigger. In the 1920s, astronomer Edwin Hubble discovered that distant galaxies are moving away from us. Even more surprising, the farther away a galaxy is, the faster it appears to be receding. This wasn't because Earth sits at the center of the universe. Instead, it revealed that space itself is expanding everywhere at once. For decades, scientists expected gravity to slow that expansion. After all, gravity pulls objects together. It seemed reasonable that the combined gravity of every galaxy might eventually bring the universe to a halt. But in the late 20th century, astronomers made a discovery that changed everything. The expansion of the universe isn't slowing down, it's speeding up. Something we cannot see is pushing galaxies apart faster and faster. Scientists call this mysterious force dark energy. We still don't know exactly what it is, but we know it exists because we can measure its effects on the universe. If dark energy continues to dominate, galaxies will keep drifting farther apart. Over billions and then trillions of years, distant galaxies will move so far away that their light will never reach us again. One by one, they will disappear beyond the observable universe, leaving each galaxy isolated in an ever-growing ocean of empty space. But expanding space isn't the only countdown taking place. Every star in the universe is also running out of time. Stars shine because they continuously fuse hydrogen into helium inside their cores, releasing enormous amounts of energy. This process creates the light and heat that make stars visible across the cosmos. However, hydrogen is a finite resource. Every second, our sun converts hundreds of millions of tons of hydrogen into helium. It has enough fuel to keep shining for another 5 billion years, but eventually, even it will reach the end of its life. The same is true for every other star. Large stars burn through their fuel quickly, living for only millions of years before ending in spectacular supernova explosions. Smaller stars burn much more slowly and can survive for trillions of years. Eventually, the universe begins to run out of the cold hydrogen gas needed to create new stars. The great stellar nurseries, the enormous clouds of gas where stars are born, grow smaller and fewer. New stars become increasingly rare until, at last, the universe produces its final generation of suns. No new stars will ever be born again. The stars that remain continue shining for unimaginably long periods, but one by one, they also reach the ends of their lives. Massive stars explode, scattering the elements they created into space. Smaller stars, like our sun, expand into red giants before shedding their outer layers and leaving behind dense, glowing remnants, known as white dwarfs. These white dwarfs no longer produce energy through nuclear fusion. They shine only because they are still incredibly hot. Over trillions of years, even that heat slowly fades until they become cold, dark objects called black dwarfs. By this stage, galaxies have begun to change. Our own Milky Way will have merged with the Andromeda Galaxy billions of years earlier, creating one enormous galaxy. For a time, the collision will trigger the birth of new stars as clouds of gas crash together. But even this spectacular event cannot stop the universe from growing older. Dark energy continues to push everything apart. Galaxies beyond our local neighborhood disappear into the distance, forever beyond reach. The universe becomes emptier with every passing age. The brilliant cosmos we know today slowly transforms into a collection of aging stars, black dwarfs, neutron stars, wandering planets, and black holes. The age of stars, the chapter of cosmic history in which humanity exists, is coming to an end. And as the last lights begin to fade, a new era begins. An era where the darkest objects in the universe become its final rulers. As the last stars fade away, the universe enters a chapter unlike anything that has come before. The brilliant galaxies that once filled the cosmos have grown dark. Planets drift through space without suns to warm them. The universe has become a cold and quiet place where only a handful of objects still remain. But the largest of them are black holes. For billions of years, black holes have consumed anything that wandered too close. Stars, planets, clouds of gas, and even other black holes. They seem almost indestructible, trapping everything that crosses their boundary, including light itself. For a long time, scientists believed black holes would be the final survivors of the universe. But in 1974, physicist Stephen Hawking proposed something extraordinary. According to quantum physics, black holes are not completely black. Tiny pairs of particles constantly appear and disappear throughout empty space. Near the edge of a black hole, one particle can fall in while the other escapes. To an outside observer, it appears as though the black hole is slowly giving off energy. This process is known as Hawking radiation. The effect is incredibly small. A black hole with the mass of our sun would take far longer than the current age of the universe to evaporate. The supermassive black holes at the centers of galaxies would survive for incomprehensibly longer. But even they cannot last forever. Over unimaginable stretches of time, every black hole slowly loses mass. They shrink so gradually that the change would be impossible to notice over billions of years. Yet the universe has plenty of time. Eventually, the largest black holes become smaller, then smaller still, until after an almost unimaginable wait, the final black hole releases one last burst of energy and disappears. For the first time since the universe began, there are no stars, no galaxies, no black holes, only a vast ocean of darkness filled with scattered particles and faint radiation, drifting farther apart as space continues to expand. This is what scientists call the heat death of the universe. Despite the dramatic name, there is no explosion or fiery ending. Instead, the universe becomes so cold and so evenly spread out that nothing meaningful can happen anymore. Think about a hot cup of coffee left on a table. At first, it is much warmer than the room around it. As time passes, the heat spreads into the surrounding air until everything reaches the same temperature. Once that happens, no more heat flows. The universe appears to be heading toward a similar fate. Over immense periods of time, energy becomes evenly distributed throughout space. Without differences in temperature or energy, there is nothing left to power stars, planets, weather, or even the chemistry needed for life. The cosmos doesn't die in an instant. It simply grows quieter, colder, and darker. This idea is connected to a fundamental law of physics called entropy. In simple terms, entropy describes the tendency for energy to spread out over time. Ice melts, fires burn out, batteries lose their charge. Left alone, systems naturally move toward a state where energy is evenly distributed. The universe seems to be doing exactly the same thing. If our current understanding is correct, the heat death is the most likely ending. But it isn't the only possibility. Some scientists have suggested that dark energy could become even stronger in the distant future. If that happened, the expansion of space would accelerate until galaxies, stars, planets, and eventually even atoms themselves were torn apart. This hypothetical ending is known as the Big Rip. Another theory is called vacuum decay. According to quantum mechanics, the universe may not be in its most stable state. If a more stable state suddenly formed somewhere in space, it could expand outward at the speed of light, changing the laws of physics everywhere it passed. If such an event were ever to occur, there would be no warning. Fortunately, there is currently no evidence that either of these scenarios will happen. Based on everything astronomers have observed, the slow fading of the universe through heat, death remains the most likely outcome. It's a strangely peaceful ending, not a final explosion, not a cosmic battle, just an endless silence stretching across an empty universe. When we think about the final day of the universe, it's easy to feel insignificant. Human history spans only a few thousand years. Civilization is a tiny moment compared with the 13.8 billion-year history of the cosmos, and compared with the trillions upon trillions of years that may still lie ahead, our entire existence is little more than a heartbeat. Yet perhaps that's exactly what makes our moment so extraordinary. We live during the age of stars. The night sky is still filled with light. Galaxies still decorate the universe. Planets still orbit warm suns. Life still has the chance to exist. One day, all of that may be gone. But not today. Tonight, if you step outside and look up, every star you see is part of an incredibly rare chapter in the history of the universe. A chapter that will not last forever. The universe may one day fall silent, but for now, it is still telling its story, and we are fortunate enough to witness it.